Okay. Hi everyone, welcome back to my YouTube channel, theMathAficionado. Today's video is going to be our video on the chapter number 3 of the Pre-Algebra course, and that is Inequalities and One-Step Equations. Okay. For the list of the chapters corresponding to this course, you can refer to my video of the course outline of the Pre-Algebra. I'll put that in the cards below or at the top right of this video. You can refer to that video for the detailed list of chapters of the course. Now today we are going to cover the chapter number 3, which is inequalities and one-step equations. So let's start. Okay. So now when we talk about this chapter, so as the name itself suggests, so this has something to do with the inequalities and also the one-step equations, right? Now here in this chapter, now this is your chapter number 3. This chapter has 4 lessons. Okay, so this chapter is further divided into 4 lessons. So the first lesson that we have here is, different ways of solving the equations. Second lesson that we have here as a part of this chapter is calculating the area and the parameter. The third lesson here is solving of inequalities, and the fourth one here is understanding inequalities as well as equations. Okay, so we are going to cover these 4 lessons as a part of this chapter. Okay, so now let's start with the first lesson. Let's start with the first lesson here, which is lesson number 1, and that is different ways to solve equation. So we talked about equation in the last chapter, right, wherein we have seen the different operations, the order of operations, and how do we solve the equations based on hit and trial, and as well as when the values of the variables are given to you. Okay, now when I talk about the different ways of solving an equation in this lesson, so we basically have 4 ways of solving the equation. Okay, so there are 4 ways of solving the equation. Now when I talk about equations in this case, so I'm talking about one-step equations. Okay, so they are going to be one-step equations. Now the 4 ways of solving the one-step equations are adding, subtracting, multiplication, and the last one is division. Okay, so we have adding, subtracting, multiplication, and division as a 4 different ways of solving the one-step equations. Now if we add the same number to both the sides of the equation, so both sides will remain equal. Okay, so we all are aware that this is how we do in the hit and trial as well, or we have also seen the same scenario in the case of inverse operations. So when we add the same number on both the sides of the equation, so it doesn't affect the equation at all, right? So both the sides still remain equal. For example, let's say if x is equal to y. Now if I add z to x on the left and z to the y on the right, so does that create the difference in the equation? No. Okay, so when we add same number, here in this case it is z, to both the sides of equation, one step equation, both the sides still remain equal. Okay, so when we added z to the both the sides of the equation which was given to us, and that was x equals y, so we have seen that it is not creating any difference to the equation clearly. Now what would be the scenario of subtraction? How do we deal with the subtraction? Okay, so in subtraction also the same scenario will occur. Okay, so if we subtract the same number, let's again take z from both the sides of the equation. Okay, so both the sides still remain equal. So even if you subtract the same number from both the sides of the equation, so still both the sides of the equation remain equal. For example, let's say if x was given as equal to y, now x and y were already there on the both the sides. Now we subtract z, which is the same number, from both the sides, so it is not going to create any difference. Clear? So this was your second case. This was your first case of addition. This was your second case of subtraction. Okay, the next we are going to see here is the case of multiplication. Okay, so the next case here is multiplication. Now let's say if you are given the equation as x is equal to y, now you multiply z on both sides of the equation, so that will not create any difference. So if we multiply both the sides of an equation by the same number, then both the sides still remain equal. Clear? So in the multiplication also, if you tend to multiply the same number, which is z in this case, to both sides of the equation, so that is not going to create any difference to the equation or the results of the equation. Clear? Now the last one here is we are going to talk about the division. So when we talk about the division, let's take the example of again x equals y. Now you'll be dividing by z on both the sides of the equation, so that will not create any difference. So if we divide the same number z on the both sides still are equal. Okay, so both the sides still remain equal. Is that clear? So we have discussed about the four cases here: addition, subtraction, multiplication, and division. Right? Now, in all the cases we have seen that if we tend to add, subtract, multiply, or divide by the same number on both the sides of the equation, so that doesn't create any difference. Now we'll be solving one final example or one final problem on this lesson. So that is, we have to solve the equation 4x minus 7 is equal to x over 3 plus 4. Now if you see this equation, how do we solve this one? How do we solve this one? So first we see a number which is negative 7. So if I add 7 on both the sides of the equation, does that create difference? No, we have just studied. So let's add 7 on both the sides. So now it changes to 4x is equal to x over 3 plus 11, because 4 plus 7 is 11. Now what we are going to do is we are going to subtract x over 3 on both the sides. So 4x minus x over 3, sorry. Now let's subtract x over 3 on both the sides. So now this changes to 4x minus x over 3, and this cancels out, so we just have 11. Okay, now what is 4x? Can we write 4x as 12x over 3? Yes. So this will be 12x over 3 minus x over 3 is equal to 11. Now 3 is common denominator, 12x minus x is on the numerator, so this becomes 11x over 3 is equal to 11. Now what do we have to do next? Now we multiply with 3 over 11 on both the sides. We can do that, right? We have just studied these concepts. So now when we multiply 3 by 11 on both the sides, so this will change to x, and on the right hand side we have 11 over 3 times 11 multiplied with 3 over 11, so which is 3. Okay, because 11 cancel out, and now this is your answer. So we solved the equation by making use of the concepts that we learned in this lesson. Okay, what was the first thing that we use? That we subtract by x minus we subtract x over 3 on both the sides, right? And the second thing what we have done here is, the first was we added 7 on both the sides. Then we made use of subtraction of x over 3 on both the sides. Okay, and then after that, once we subtracted x over 3, we have 11x over 3 is equal to 11. Now we multiplied by 3 over 11 on both the sides. So you see we have used the first 3 cases that we learned above. Okay, and finally we are getting the answer as x is equal to 3. So does that make sense? How do we make use of the different ways of solving the equation, wherein the ways I mean to say by adding, subtracting, multiplying and dividing by the same number on both the sides. So this was all about lesson number 1 in the chapter number 3, which was different ways of solving the equations. Okay, now let's move to the second lesson, which is calculation of area and the parameter. So now here lesson number 2 is calculation area and parameter. Okay, so as we have seen the list of chapters, now we are starting with the number 2, which is calculating the area and parameter. Okay, so when we talk about this lesson, so first we will see what do you mean by, what do you understand from the parameter. So the parameter is the length of the outline of a shape, or you can say the outer boundary of the shape, and to find the parameter of a rectangle or square, you have to add the lengths of all the 4 sides. Okay, so when I say all the 4 sides, so let's say if this is a rectangle and this is your square. Okay, so now here x is your length, this is rectangle, and this is your square. Now when I talk about the rectangle, so x is the length and y is your, or So x is your length and y is your width. In the case of the square, we know that all sides equal. Okay, so this will be x and this will also be x. Clear? So now when I talk about the perimeter of the rectangle, so that would be x plus y plus, now here also there is x and here also there is y, right? So what we have as a parameter is basically adding all the lengths, adding the lengths of all the four sides. So that will be x plus y plus x plus y. So that is 2x plus 2y, and that becomes 2 times x plus y. So now this is your parameter of rectangle. Okay, now when it comes to square, here we have the parameter of square as x plus x. Now this is also x and this is also x. So it is x added 4 times, so that is 4 times x. So when it comes to parameter of rectangle, that is 2 times x plus y, where x is your length and y is your width. Okay, let me write it. So x is your length, y is your width. But in the case of square, we know that all sides equal. So length will also be x and the width will also be x. Hence the parameter of the square will be 4 times x. Okay, we will see the example next. So next example here is, we are given a rectangle wherein the length is given as 7 and the width is given as 4. Now we know that what is x here, or you can say the length 7, and what is your width, which is your y, that is 4. What was the parameter of rectangle? 2 times x plus y, as we have studied above, right? So that is going to be 2 times 7 plus 4, which is 2 times 11, and that is 22. Okay, so that is going to be 22 units. Does that make sense? So this is how we find the parameter of the rectangle given the length and the width of the rectangle. Now we have studied about the parameter. Now let's parameter of the rectangle. Now let's take the case of a square. Let's say if the length of the square is given as 4, so obviously this will also be 4, right? So what is x in this case? 4. Now the parameter of the square would be 4 times x, which is 4 times 4, and that is 16 units. Okay, so the parameter of the square in this case is 16 units. Clear? Now after parameter, we talk about the area of the shape. So now when I talk about the area of the shape, so obviously first we are going to talk about the area of the rectangle. So what is area for in the first place? So this is the measurement of the surface of the shape. So this is basically the measurement of the surface of the shape. To find the area of a rectangle or square, you need to multiply the length and the width of a rectangle or a square. Okay, so how do we find the area of the rectangle or a square? Let's say if this is your rectangle, again I'm taking the same thing, x being the length and y being the width. Okay, so area here would be given with area of the rectangle would be x times y, or you can say length times width. Okay, so area is given as which is basically the area of the surface of the shape. And area, for finding the area, we multiply the length and the width of the rectangle. So here the length is x and width is y. That's why the area of the rectangle is given as x times y. Okay. Similarly for the square, how we are going to write it as? Let's say if this is a square. Now here this will be x, so this will also be x. So the area of the square will be given as x times x, which is x square. Why? Because here length is also x and width is also x, right? So the area of the square will be x times x, which is x square. Let's take example. If you are given a square with the side as 5 and this also as 5, so what will be the area? Area would be x square, so that is 5 square, and that is 25. Okay, so area of the square here is 25. Clear? One final example. So question here is calculate the parameter and the area in feet. Now this is 9 feet and this is 5 feet. And this is obviously a rectangle because we have unequal length and width. Okay, so now when I talk about this one, so the first we will be finding the parameter. Okay, so parameter is 2 times x plus y. What is x here? 9, and y is 5 feet, right? So 2 times x plus y would be 9 plus 5, and that is 2 times 14, 28 feet. The unit of the parameter will be feet because it's a adjust addition of the lengths, right? But when it comes to area, that is x length times width, which is x times y, so that would be 9 times 5, 45. But in this case the unit is going to be feet square because you are multiplying the length with the length, so that is going to be the unit square. Okay, so this was all about how do we calculate the area and the parameter of a shape. Okay, so this was your lesson number 2 under the chapter number 3, and that was calculating the area and the parameter. Now the next chapter that we are going to the next lesson that we are going to start is solving the inequalities. Okay, so solving inequalities. Okay, so this is your lesson number 3. So here we'll be studying about how do we solve an inequality. We have already seen how do we solve an equation. Now we will be seeing how do we solve an inequality. Okay, so when we subtract or add the same number on both the sides of the inequality, then the inequality, or you can say truth of inequality, doesn't change. Okay, so the way we have seen that when we add, subtract, multiply or divide a same number on both the sides of a one-step equation, it doesn't change, right? Similar goes with the inequalities as well. When we add the same number or subtract the same number on both the sides of the inequality, the truth of the inequality doesn't change. When I say truth, because here inequality either holds true or false, that's why we call that as truth. Okay, for example, or you can say how do I justify that mathematically? So that is, For example, x is greater than y, so x less than y. Now here x was greater than y, I added z on both the sides, so this will hold true. Here also when I add z, so that will become less, so that will also hold true. Okay, so what I've basically done is these are the two initial inequalities, two initial inequalities we started off with. Okay, so now here we added z on both the sides and the truth of the inequality didn't change. Similarly, so this was your case of addition. Similarly, we will have the case of subtraction. X plus z, sorry, here we are subtracting, so x minus z greater than y minus z, and x minus z less than y minus z. Okay, okay, so even the addition as well as subtraction, they both didn't create any difference. Let's take a proper example of the same. If you have x plus 3 is greater than 9, now what you are going to do is you are going to use the subtraction of 3 on both the sides. So that will be x plus 3 minus 3 greater than 9 minus 3. So what you have done here is subtracted 3 on both the sides. Okay, so that means it will still hold the truth of the inequality. So now this has become x and this has become 6, and you can say that x is greater than 6. Clear? But now this was quite easier when it was case of addition and subtraction, but now it becomes trickier when it comes to division or multiplication. So a little bit trickier when it comes to division, multiplication. Okay, so the case of division and multiplication can be a bit trickier. Why I'm saying so? Because here, let's say if we start with inequality x greater than y, now when I multiply with z on both the sides, okay, so I have multiplied with z on both the sides. Now this is going to give us what? Or so this is your case of multiplication. This is your case of division is what I'm taking next. Okay, so let's say if it was x over z divided by y over z. Okay, so now this case is only going to hold true only when z is positive. Situation will change if z is less than 0. Okay, this will also hold true when z is greater than 0. If z is less than 0, then the situation will change. Why this is happening? Because suppose if you multiply with negative numbers, suppose if z goes 0, that means z is a negative number. Okay, so in that case, whenever you multiply with negative on both the sides, so while cancelling the negative, your inequality sign changes. Okay, so while dealing with the negatives multiplied or divided on both the sides, the sign of inequality changes. Okay, so that is the issue. So while dealing with the negatives on both the sides, either in the form of a multiplication or division, so then the inequality sign changes. I'll show you how. So let's say if the initial inequality was x greater than y, okay, you multiplied with the z. So now in this case, we are talking about z being less than 0, which is a negative. So this will be the situation. Okay, so now you see that the inequality sign has changed. Similar goes with the division. So here the inequality sign will again change to less than. Okay, so here this is your multiplication and this is your division, and you can see that the inequality sign has changed because z is less than 0, because z is a negative number. Clear? I'll show you the example and that will make things more clear. Okay, so let's say if you have x over negative 2 greater than equals to 3. Now obviously in order to get rid of this negative 2, you will be multiplying with negative 2 on both the sides. And what is negative 2? A negative number, right? So this will change to x over negative 2 multiplied with negative 2 greater than equals to 3 times negative 2. Correct? Let me not write it with a cross, rather we write with the dot. Okay, so now when we cancel out this negative, so that will be x greater than equal to negative 6. Sorry, I forgot to change the sign. Since that was a negative number, so the sign will change. Okay, so you can see that here inequality sign has changed from greater than equals to less than equals to. Clear? So this becomes your answer. I hope that makes sense. Let's take the final example. 2 minus 3x is less than 14 and we have to solve this. Okay, so now here this is the inequality that is given to us, wherein 2 minus 3x is less than 14. Now how do you solve this one? That is the challenge, correct? So what we are going to do is, first we will try to get rid of this constant, which is 2. So negative 2 on both the sides. I can definitely do that. And here I don't have to change the sign because this is not a case of multiplication or division, rather it is just subtraction. So after this changes to negative 3x less than 14 minus 2, which is 12, right? So this is 12 on the right. Okay, because this cancels out. Now when negative 3x is less than 12, so what I'm going to do is I'm going to divide by negative 3 on both the sides. So now this will change the inequality to greater than, and this cancels out. So x is greater than negative 4, and that becomes my answer. Okay, so that is x greater than negative 4. Now here why the sign changes? Inequality changes to greater than because of the division. Okay, here inequality sign doesn't change because of subtraction. I hope that is clear now, right? So in the first case it was subtraction, so that's why it didn't change. But in the case of multiplication and division, the inequality sign changes, and hence we change the sign and it became greater than. Clear? So this was all about lesson number 3, okay, which was all about solving the inequality. So we have seen the cases again, the 4 cases of addition, subtraction, multiplication and division, wherein we have studied that in the case of addition and subtraction the sign doesn't change, okay, even if we are adding or subtracting a negative number. But in the case of multiplication and division, if we are multiplying and dividing by a negative number, then the sign definitely changes for the inequality. Now the last and the final chapter that we have here is lesson number 4, which is understanding the inequalities and equation. So the last chapter that we have here is understanding the inequalities and equation. Understanding inequalities and equations. Okay, so let's start with this lesson, and this is the final lesson under this chapter. Okay, so now we have seen, or we have understood our knowledge on the equation solving in the previous lessons. Now we need to solve some verbal problems. Okay, so we need to solve some verbal problems. So when I say verbal problems, we mean the problems that we need to translate an equation by ourselves. The problems we need to translate by ourselves. Okay, I'll give you the example. Example here is, there's a Leonard earns $60 a day after working for few days. Leonard has earned $240. After working for a few days, he has earned $240. How many days has Leonard worked is the first question. And also we will be denoting, so we denote the number of days he has worked as X. Okay, so he earns $60 a day. After working for few days, he has earned a total of $240. Now we are going to denote X being the number of the days he has worked. Okay, and you have to find how many days the Leonard has worked. How many days he has worked is our question. Now if he is working if he is earning $60 in one day, and X being the number of days. Okay, so number of days is X. Earning per day is $60. So what is the total earning in terms of X? 60X after X days, right? And also we are given that the total earning that he has is 240. So we are going to equate that with 240. So now I have the equation, which is 60X is equal to 240, right? Now in order to solve this equation, what do I need to do? So as we have learned in the case of one-step equation, if we divide by the same number on both the sides of the equation, then it doesn't change anything, or you can say it doesn't create any difference, right? So what we are going to do is we are going to divide by 60 on both the sides of equation. So this gets cancelled out, so X would be equal to 4. Okay, so we can say that to earn $240, Leonard has worked for 4 days. And that's your answer. Okay, so he has worked for 4 days in order to earn $240. Does that make sense? So this is how we solve a word problem based on one step equation. Let's see the one more example. Question number 2. Now here we are given Margaret is paying $1,500 in rent for her apartment every month. Okay, so every month she's paying $1,500 for the apartment as a rent. Margaret Town sorry Margaret won $12,000 in Vegas and wondering how many rent she can afford to pay with this winning. So basically she has won $12,000 in Vegas and she's wondering how many months of rent she can pay with this winning. Clear? So this is your problem statement and you have to figure out how many months she can pay the rent for using the amount that she has earned or win in the Vegas. Clear? So this is your word problem and we have to see how do we solve this. Now let's start with the solution. So now $1,500 is her per month rent, correct, for the apartment. And let X be the number of months. Okay, so can I say that the 1,500 multiplied with X will be the total amount that she is going to pay for the rent of the apartment, and that she is aiming with the winning amount, which is 12,000. So this is the winning amount. Okay, this is your per month rent. So now we know that if we divide by the 1,500 on both of the sides, so it doesn't create any difference with the equation. So 1,500 times X over 1,500 is equal to 12,000 over 1,500. Gets cancelled out. So X will be equal to 2 zeros get cancelled and this is 8. Okay, so the value of the X here is 8. That means she can pay for, so she can pay for 8 months of her apartment's rent from the winning amount of $12,000 at the rate of $1,500 per month as rent. Okay, so she can basically pay for 8 months of her 1500 rent as a monthly rent to her apartment from the winning amount of $12,000 that she won in Vegas. So that's your solution to this problem. So this is how we solve the word problem based on the one-step equations. I hope now it makes sense. How do we solve the equations? What are the different cases in the case of equations as well as inequalities, and what we have to take care of while being in multiplication or the division in the case of inequality. Okay, it does change sign, but in the case of addition and subtraction, it doesn't create any significant any difference in fact. Okay, so these were the 4 lessons as a part of this chapter number 3, which was inequalities and one-step equations. Okay, and the 4 lessons we have covered in detail with theory as well as examples. Okay, so that's all for today. If you found this video helpful, please don't forget to like, share and subscribe to my channel. Your support is what motivates me to keep creating such content with love and dedication. So I would be happy to hear your thoughts. Please let me know in the comments how you like this session. Okay, how you like this video, and any suggestions if you have for the improvement, that also you can let me know in the comments. Okay, and for referring to the list of the chapters, please refer to the cards below. So it has the course outline video, and also you can refer to the top right of the video. Okay, so thank you so much. That was all. Thank you.